everyone, my name is Peng Liang Zhao, and this is my project presentation for EEL 6935. My topic is deployment of smoke sensors for maximizing detection probability. First, I can talk something about the problem I want to solve. The smoke detection network is widely used in hotels, schools, and many other places to detect fire or smoke. In this project, the smoke detection network is based on the wireless sensor networks. I mainly focus on the localization and deployment of the sensors for better detection probability in the network. First, sensor localization is very important in the smoke detection network. It is very important for the network to tell the user where the sensor node is in the network. Second, the main problem in the project is how I deploy the sensors in the monitoring area in order to get the maximizing detection probability. My solution to the problems. For the localization of the nodes, I will use MDS map algorithm to solve the problem. Second, for the detection probability, I will mainly discuss the coverage rate of the sensor nodes in the smoke detection network. I assume that the sensor in the networks is reliable. In another way, the detection probability of the smoke is equal to the coverage rate of the sensor networks. First, I will talking about the localization of the sensor nodes. Multiple dimensional scaling is a means of visualizing the level of similarity of individual cases of a dataset. The MDS can be used in the case that all pairwise distance in the network are known. Then the coordinates can be given by the classic MDS. The principle of the MDS is to convert distance into an inner product matrix. The inner product matrix and the vector shall be unknown coordinates. MDS map could compute the shortest path between all pairs of the nodes in order to give the missing entries of the distance matrix. Here is what I have set for the network parameters in the first question. And the number of unknown nodes is 10, 20, 30, 50, and 100. Number of reference nodes is 4. The communication radius of the sensor node is 5. Size of the network is 8 plus 8. Here, I will use a two-dimensional space for the network. And I want to talk something about the MATLAB code. Here I give a main code which is named project1.m. This is the function to use MDS map algorithm to find the localization of the sensor nodes. And I defined two functions to help solve the problem. The first one is L2 distance point m. The function of this function is to calculate the distance between two nodes. Another one is matrix optimal. The matrix optimal here is to optimize the repeat iterative matrix. Here is the result. We can see when the unknown nodes is 10 and 20. And I want to make a remark that here the unknown node is marked by red star, and the reference node is marked by black circle. The localization of the unknown nodes is marked by blue. Here is when n is 30 and 50. Here in this image shows when n is 100. Result of the project 1.m conclusion. From the result, the program could give the localization of the sensor nodes reliable. The accuracy of the program is also very good. The reason is that the localization coordinates marked by blue and the coordinates of the unknown node marked in red could match great. And now I want to talk about the detection probability of the network. Here, in order to approach this problem, I give some basic assumption about the problem. First, the sensors used in the smoke detection network is 100% reliable, which means that in the network, the sensors will not be defective. Second, the sensors used in the smoke detection network have an effective sensing radius of 60. Third, the sensors used in the smoke detection network have a sensing angle. In addition, the detection of sensors used in the network could be modified. And here is another two assumptions. The first is about the network used in this project. Assumptions about the network size and the monitor area. Here, the monitor area and the network size is also a two-dimensional space. Another about the deployment of the sensors. Because the monitoring area is assumed to be a square area, the deployment of the sensors could be different kinds of topologies. And here I decided to deploy them randomly in the square area. The advantage of this kind of deployment of the sensors is that I could modify the angle of the sensors to get a maximizing coverage rate. And after all those assumptions, I can give a conclusion that here the direction probability now is equal to the coverage rate of the sensors in the area. So I want to discuss how the program 2 works, shows in steps here. First, I will give the size of two-dimensional network. Second, give the number of the sensors in the network. Third, randomly deploy all the sensors in the area. Each sensor node have an initializing sensing direction. After getting the direction, change the direction to a specific angle, and repeat step 4 for the defined times. Finally, I can display the image of the final distribution of the sensors and the angles of the sensors. Then I can display the coverage rate of the sensors, which here is the detection probability. Here is the parameters of the networks in program 2. We can see the size of the network is 500 plus 500. The number of sensors will be 50, 100, 200, 300, and 400. Effective sensing radius is 5 meters. Effective sensing angle of the sensor is 90 degrees. And the modified time of the sensor is 50. Here's the result. When the sensor's network is 50, we can see from the left image is the coverage rate. The highest coverage rate is about 0.448. And in the right image, we can see the final distribution and angle of the sensors in the network. And this one shows when n is 100, the probability is about 0.689. Here is when the sensors is 200, and the probability and coverage rate is about 0.913. And this is when sensor node is 300, the probability is about 0.975. And this is when the number of sensor nodes is 400, the probability is about 0.985. Here is summary and conclusions. With the increasing of the number of sensor nodes in the network, the coverage rate or the detection probability is also increasing. But the coverage rate will increase slowly when the number of sensors of nodes is big enough. Note that when n is 300 and n is 400, the coverage rate is almost the same. To increase the coverage rate, it is not quite efficient when the number of sensors nodes is big enough. Deployment of sensors will also affect the coverage rate. Here I give a table to show that when the number of sensors is 300 or 400, the probability is almost the same. Conclusions for my project. For the first problem, the localization of the sensor nodes in the network, the MDS map algorithm could give the coordinates of the unknown sensor nodes. From the result, the program could give the localization of sensor nodes reliably. The accuracy of the program is also very good. For detection probability, based on my assumption, the detection probability is equal to the coverage rate. From the result, the coverage rate will increase with increasing of the numbers of the nodes in the sensor network. However, the coverage rate could not increase dramatically if the number of sensor nodes is big enough. The number of nodes in the smoke detection network is very important, but how to deploy them is also very important. From the result, the detection probability is almost the same when the number of nodes is 300 and 400. The deployment of the sensors in the network shall be considered in the design and use of the smoke detection network. And thanks for watching my PPT. Here I'll show my program in MATLAB. Here is the program for the first question, first problem. And this is the defined function to calculate the distance between two nodes, and this is the function defined to optimize the interactive matrix. And here I will show that when n is like 100, we can give the result, and when n is 50, like here is the result. And for project 2, I will display when the number of the nodes is 50, 100, 200, 300, and 400. Here is the number of sensor nodes in the smoke detection network is 50. We can see the result of the program. The probability is about 0.445. And now we try 100. The probability is about 0.682. And we're going to try 200. Here, the maximum probability is about 0.885. And now we're going to say 300. Also, the probability is about 0.968. And finally, we're going to show 400. Here we can see the determined probability is about 0.985. And thank you for watching my presentation. Thank you.